Hello, my name is Nagsepuraj and today's my topic is about free wireless sensing networks. Device for free wireless sensing and challenges and opportunities and applications for free wireless sensing devices. In the introduction is that recent development of the DNS have showed that the wireless signals can be utilized not only for the communication medium to transmit data but also as an enabling tools for realizing non-intrusive devices free sensing. The DFS has many potential applications. For example, the human detection and localization, the human activity and gesture control and surveillance and elder or patient monitoring system and emergency rescue and so on. With the development and maturity of the DFS or DFSWS, we believe that it can be eventually empower traditional wireless networks with the augmented ability to sense the surrounding environment and evolve the wireless communication networks into intelligence sensing networks that could sense a human scale context and information within the development area of the network. The research field of the DFSW was emerged quickly recently. These articles tries to provide an integrated picture of the emerging field and hopefully inspire future research, and significantly we represent the working principle and system architecture of the DFSW system and review its potential application and discuss research challenges and opportunities. The device sensing system is an emerging technology that could estimate the presence of local motion activity and gesture of the control without equipping him or her with any device. The wireless signals can be widely recognized as the most successful medium to realize communication. No matter where they are nearly inevitably wireless signals around us. For example, 3G, Wi-Fi, 4G, Wi-Fi, FM, TV, etc. A person within development area of the wireless network influences the wireless signals in a predictable way, which renders it feasible to sensible the human state of analyzing the wireless signal patterns and characteristics. Compare with other states of art sensing technologies such as cameras and wearable sensors, the DFSW does not require specially deployed sensing devices. Can work well under smoky or dark conditions. Aforementioned advantages makes the DFS an ideal technique for preserving sensing applications. Furthermore, DFSW enables traditional wireless networks and augment the abilities to sense the surrounding environment. The research field for the DFSW has emerged and quickly developed recently. The researchers have utilized different intrinsic parameters. The research field of the augmented differential reflect that, however, due to the insignificant difference between the intrinsic patterns, the different approaches and the different applications, the field of DFSW is somewhat fragmented. Now let us see the working principle of the architecture signal. Let us say if you want to detect the target, then we have to send the wave. Then we have to send the wave to the target, and we have to check the amplitude and phase of the targets, and we can see whether the target is in the area or not. This is a simple architecture of a simple wireless sensing device. These sensing devices can be very intricate too. For example, if you want to detect the target's current position and whether the target is in the position or not, we have to use various nodes. To the target and sensing devices to activate to see the position of the target. And to see the position of the target, we have to use some kind of filters. Then we have to convert the features into multi-domain features to extract the information whether the target is sitting, standing, jumping, moving, etc. By using this, we have to use some type of algorithm to generate some geometric method or compressive sensing or random forest method to sense the targets. and we can see that these devices can be used for device to extract the features from the device architecture.
And why they are often an important part of an IoT solution. When we want to rapidly prototype IoT solutions, we often use Raspberry Pi, the ESP32, or even Android. This is all fine for prototyping, but a real-world deployment is a different ballgame altogether, and so on. For example, let us consider a smart city project. Such a project may involve deploying several thousands of sensors all over a city, spanning an area of several hundred square kilometers. Often, these sensors will have to run on batteries with minimal or zero human assistance. Furthermore, the radio network may have bandwidth and quality constraints, and the project will also most likely have budget constraints. This is where the wireless sensor networks come into play. A wireless sensor network comprises of a large number of sensor nodes arranged in a variety of topographical configurations like the star, ring, and mesh. These sensor nodes are usually battery or solar operated and are designed to operate on very little power. Often, the radio transmission range of the sensor nodes is a few tens of meters, so the network nodes will have to relay the data from sensors all the way to the gateway, from where the data can be sent to the cloud via either wired Ethernet, cellular, or Wi-Fi networks. Thus, the data in a wireless sensor network takes a multi-hop path to reach the sync node or the base station. And what are the benefits of having this sensor network wireless? Well, to start with, it is a lot cheaper to build a wireless network rather than have a wired sensor network. Secondly, with wireless, the sensor network can be configured and reconfigured into various topographies like mesh, star, etc. very easily. Sensor nodes can also be added to and removed from a wireless network a lot easier than a wired network. Now, let us see what are the components of a typical wireless sensor node. The sensor is just one component of a wireless sensor node. The sensor is just one component of a wireless sensor node, usually it on. Now, let us see what are the components of a typical wireless sensor node. The sensor is just one component of a wireless sensor node. Usually it also has a power supply, a microcontroller, and a radio transceiver. Put simply, all this data from various sensors in the wireless sensor network take a multi-hop route to the base station or gateway, from where the data is funneled to the cloud IoT platform like AWS IoT, where all this data is cleaned and analyzed to come with actionable insights. Typical sensor nodes are used to measure temperature, humidity, vibration, light, heat, movement, moisture, and so on. The results from this video.
Now let us see what are the different types of potential applications of that types of wireless sensor nodes. And the potential applications are the model for the complex human state, and wireless sensing for big data analysis, and security applications and privacy. And we can also use the multi-domain feature from the above wireless sensor to detect the different types of challenges and opportunities for the applications in the wireless sensor division. And we can also have large scale multi-target detection and have the targets move around the city, and can also detect the target's movements, target actions, and etc. In this article, we can say that we have discussed about data acquisition, pre-processing methods, and extracting the features of the data, in the wireless sensor network, and the application and main potential and applications for the wireless sensor data, and analysis of the wireless sensor data. The main purpose of the article is to provide a comprehensive overview and the emerging field of hopefully to motivate the researchers and engineers to move forward with more creative designs on DFWS. And thank you.